Good morning to all. I am Geeta, Assistant Professor from ECE Department, Rohini College of Engineering and Technology. I am going to handle the subject on Communication Engineering. So now I am going to discuss about the topic on Convolutional Codes. So on completion of Convolutional Codes, the students will be able to define convolutional codes, define constraint length. First, what is meant by convolutional codes? A convolutional coding is done by combining a fixed number of input bits. So the input bits are stored in a fixed length shift register. So they are combined with the help of mod 2 orders. So this operation is equivalent to binary convolutional, and hence this will be called as a convolutional coding. So this is the diagram for the convolutional encoder. So above we are having the message bits as the input M, M1 and M2. So the M, this bit will be represent a current message bit. So this bit is a part of shift register where M1 and M2, so these two bits are previous two successive message bits are stored in those two flip-flops. Those two bits M1, M2 represent straight of the shift register. So here we are having two outputs, 1 and 2, that is V1 and V2. So in the convolutional encoder where k is equal to 3 and small k equal to 1 and n equal to 2. So what is the main operation will be done in that convolutional coding? Whenever the message bit will be shifted to a position M, so the new value of V1 and V2 are generated depending upon M, M1 and M2. So we have to store the previous two message bits. The current message bit is present in M. So V1 will be equal to M plus M1 plus M2, that is mod 2 operation will be done, where V2 equal to M plus M2. The output switch first samples V1, then V2. So the shift register then shift the content M1 to M2 and the content M to M1. So the next input bit is then taken and stored in M. So again we are having V1 and V2. So these are generated according to his new combination of M, M1 and M2. So the output switch then samples V1 and V2. So the output bit stream for successive input bits so will be X is equal to V1, V2, V1, V2, V1, V2 and so on. So here every input message bit, two encoded output bits V1 and V2 are transmitted. So in other words, the single message bit, that is the encoded code word, is 2 bits of his convolutional encoder. So number of message bit, that is k is equal to 1. The number of encoded output bits for one message bit b is equal to 2. Therefore the code rate for this particular encoder is r is equal to k by n, that will be equal to 1 by 2. So if the encoder of figure, this will be observed whenever a particular message bit enters into a shift register, it remains in the shift register of 3 shifts. For first shift, the message bit is entered in position M. For second shift, the message bit is shifted in position M1. For third bit, the message bit is shifted in position M2. So based on that, the fourth shift is the message bit is declared or simply lost by overwriting. So we know that V1 and V2 are the combination of M1, M, M2. Since single message bit remain in M during first shift, in M1 during second shift and in M2 during third shift. So this will be mainly influences the V1 and V2 for the 3 successive shift. So then we have to see the constraint length. So that is denoted by K. So the constraint length of the convolutional code is defined as the number of shifts in which the single message bit will be influences the encoder output. So this will be mainly termed in message bits. For example, we have to take the constraint length in that figure k is equal to 3 bits. So because of this encoder, a single message bit influences the encoder output for 3 successive shifts. So at the 4th shift, the message bit is lost and it has no effect on the output. So this is the states of the encoder, that is M2 and M1. The state of the encoder is 00A, 01B, 10C, 11D. The first question is based on the convolutional codes. Is the cyclic codes are designed using dash. Thank you.